Hello everyone. I would like to present about tau plus n as a chromatic root of a graph where tau is the golden ratio and as you know is a 1 plus a square root of 5 over 2. Okay, I use some paper here and I show you some of them. For example, in this paper entitled Chromatic Zero and the Golden Ratio, we prove that all natural power of the golden ratio cannot be a root of any chromatic polynomial. So tau n cannot be a root of chromatic polynomial. If so, as you know, tau 2 is equal to tau plus 1. We know that tau 2 is equal to tau plus 1. So tau 2 is not a chromatic root. Of any graph. But we can ask about another numbers such as tau plus n for n greater or equal to 2. Let me to show another paper here. In this paper, use entitled Algebraic Integer as Chromatic and Domination Roots. We have this theorem 2.8 that says if alpha is a chromatic root, then for any natural number alpha plus n is a chromatic root. In this paper, we have shown that tau plus 3 is a chromatic root, as you see here in theorem 2.14. So tau plus n is a chromatic root for every n greater than or equal 3. Let me to transfer this result to my presentation. Sorry. Okay, what remains about the number tau plus 2, okay? So here tau cannot be a chromatic root, tau plus 1 also cannot be a chromatic root, but tau plus n can be a chromatic root for n greater than or equal to 3. Now we can ask this question that what about tau plus 2? And I asked this question more than I think 10 years ago, and this has been a famous question in the roots of chromatic polynomial. Recently I found that Roy in Australia and his colleagues in this paper that I think published recently in Journal of Graph Theory, entitled Chromatic at 2 and at the Brahan number B10, they constructed an infinite family of 3 connected graphs such that for any k greater than or equal 1, there is a member of the family with 2 as a chromatic root with multiplicity at least k. And here I drawn from the paper of Roy 2 graphs G1 and G2. You see here 2 graphs G1 and G2, and the chromatic polynomial written here. As you see, Q2 minus 5 Q plus 5 is a factor of this chromatic polynomial of G1 and also for G2, and this is a minimal polynomial for tau plus 2. So chromatic polynomial of G1 and G2 have tau plus 2 as a chromatic root. So we have this result or corollary that tau plus n are chromatic roots. for any n greater than or equal to. But for n0 and 1, tau plus n cannot be a chromatic root. Thank you very much. Bye.